Alright, this is Janus from Arthur Koestler. It's a summary of a lot of his stuff, and like a look back. But Chapter 13, Physics and Metaphysics. Half of my friends accuse me of an excess of scientific pedantry. The other half of unscientific leanings towards preposterous subjects such as extrasensory perception, ESP, which they include in the domain of the supernatural. However, it is comforting to know that the same accusations are leveled at an elite of scientists who make excellent company in the dock. Thus, the opening paragraph of The Roots of Coincidence. Since then, the elite of scientists has apparently grown into a majority. In 1973, the New Scientist, that much-respected English weekly, sent out a questionnaire to its readers, inviting them to express their opinions on the subject of extrasensory perception. Out of the 1,500 readers, nearly all of them scientists and engineers who answered the questionnaire, 67% regarded ESP either as an established fact or a likely possibility. Even earlier, 1967, the New York Academy of Science held a symposium on parapsychology, and in 1969, the American Association for the Advancement of Science, the equivalent of the British Association, approved the application of the Parapsychology Association to become affiliated to that august body. Two previous applications had been rejected. The approval of the third was a sign of the changing intellectual climate, and for parapsychology, the ultimate seal of respectability. Accordingly, it seems to me unnecessary to recapitulate here the progress of parapsychology from spiritistic seances in darkened Victorian drawing rooms to a modern empirical science employing computerized statistics, Geiger counters, and other sophisticated electronic equipment. In the pages that follow, I shall no longer be concerned with the question whether telepathy and kindred phenomena exist, which in view of the large body of accumulated evidence I have come to take for granted, but the implications of these phenomena for our worldview. That worldview, insofar as the educated layman is concerned, places parapsychology and physics at opposite ends of the spectrum of knowledge and experience. Physics is regarded with the educated layman as the queen of the exact sciences, with direct access to the immutable laws of nature, which govern the material universe. In contrast to this, parapsychology deals with the subjective, capricious, and unpredictable phenomena which manifest themselves in apparently lawless ways, or in direct contradiction to the laws of nature. Physics is, as the academic jargon has it, a hard-nosed science completely down to earth, whereas parapsychologists float somewhere in nebulous cloud cuckoo land. This view of physics was indeed perfectly legitimate and immensely productive during the roughly 2 centuries when the term physics was practically synonymous with Newtonian mechanics. To quote a contemporary physicist, Fritjof Capra, questions about the essential nature of things were answered in classical physics by the Newtonian mechanistic model of the universe, which, much in the same way as the Democritean model in ancient Greece, reproduced all phenomena to the motions and interactions of hard, indestructible atoms. The properties of these atoms were abstracted from the macroscopic notion of billiard balls, and thus from sensory experience. Whether this notion could actually be applied to the world of atoms was not questioned. Or in Newton's own words, it seems probable to me that God, in the beginning, formed matter in solid, massy, hard, impenetrable, movable particles of such sizes and figures, and with such other properties, and in such proportion to space as most conduced to the end for which he formed them, and that these primitive particles, being solids, are incomparably harder than any porous bodies compounded of them, even so very hard as never to wear or to break in pieces, so ordinary power being able to divide what God himself made one in the first creation. If you leave out the reference to God, the above quotation dating from AD 1704 still reflects the implicit credo of our educated layman. Of course, he knows that formerly indivisible atoms can be split with sinister results, but he believes, if he give any thought to the matter, that inside the atom there are other truly indivisible billiard balls called protons, neutrons, electrons, etc. However, if he were sufficiently interested, he would also discover that the giant atom smashers have made mincemeat of protons, neutrons, etc., that the ultimate, to date, elementary particles are called quarks, and that some quartz have a physical attribute called charm. A term borrowed from Finnegan's Wake, quark in German means curds or soft cheese of a pungent and generally evil-smelling sort. So it makes you think of, again, Qliphoth. The exotic terminology of subatomic physicists also includes the Eightfold Way, strangeness, and the bootstrap principle, which goes to show that they are well aware of the surrealistic nature of the world they have created. Behind the schoolboyish humor, there is the... I'm trying to read this through the camera itself. There's the odd recognition of mystery. For on this submicroscopic level, the criteria of reality are fundamentally different from those we apply on our macro level. Inside the atom, our concepts of space, time, matter, and causality are no longer valid, and physics turns into metaphysics with a strong flavor of mysticism. And again, just taking the whole analogy about us going around the sun on the Earth, there's weather patterns from the sun itself. So our experiments on Earth, they would have to be done, almost year-round to get full, empiricism, because you never know what we're going. So that's why astrology does have some, even scientific basis, in just in the sense that there's magnetic poles, there's meteor showers, there's solar rays, there's cosmic rays, and that all changes. It's variable. Hidden variables is 333 when you add it up, like using the Hebrew applied to English. And 333 is all about, the guardian of the abyss, and it's all about order and chaos. And so it's just, think about hidden variables, 333, all these, there's a lot of connections in that. So inside the atom, our concepts of space, time, matter, and causality are no longer valid, and physics turns into metaphysics with a strong flavor of mysticism. As a result of this development, the unthinkable phenomena of parapsychology appear somewhat less preposterous in the light of the unthinkable propositions of relativity and quantum physics. One such proposition I've already mentioned, the principle of complementarity, which turns the so-called elementary building blocks of classical physics into Janus-faced entities that behave under certain circumstances like hard little lumps of matter, but in other circumstances as waves or vibrations propagated in a vacuum. As Sir William Bragg put it, they seem to be waves on Mondays, Wednesdays, and Fridays, and particles on Tuesdays, Thursdays, and Saturdays. We have seen that the sum of the pioneers of quantum physics, as well as their contemporary successors, regarded the principle of complementarity as a fitting paradigm for the mind-body dichotomy. This was cheering news to parapsychologists. We must remember, however, that Cartesian dualism recognizes only the two realms of mind and matter, whereas the present theory proposes a series of levels equipped with swing gates, opening now this way, now that. Both in our daily behavior and on the subatomic level, the gates are kept swinging all the time. And so I'm just thinking, the whole mind-body thing, the word psychosomatic happens, again, to equal 666. 666 is all about the heart and the mind, also, matter too. So it's all about, it is psychosomatic, and it's all about, like the word geometric emergence. It makes you think of, 666 is hexagon, carbon, snowflakes, basically, like the geometric emergence and these fields, and there's a lot. I've already written about the magnetism and the Kabbalistic hard drive, and the quantum hard, the hieroglyph or the holographic monad. All these things slowly came to me, like while I was deciphering things, but there's a lot of things that correspond, again, with what so-called parapsychology and quantum mechanics and technology. It's only a matter of time. The concept of matter waves, launched in the 1920s by de Broglie and Schrödinger, completed the process of the dematerialization of matter. It had started much earlier with Einstein's magic formula E equals mc squared, which implies that the mass of a particle must not be conceived as some stable elementary material, but as a concentrated pattern of energy locked up in what appears to us as matter. The stuff of which protons and electrons are made is rather like the stuff of which dreams are made, as a glance at the illustration on page 246 suggests. It is an example of the type of events which take place all the time in the physicists' bubble chambers, where high-energy elementary particles collide and annihilate each other to create new particles which give rise to a new chain of events. The particles in question are, of course, infinitesimally small, and many have a lifetime much shorter than a millionth of a second, yet they leave tracks in the bubble chamber comparable to the visible trails which invisible jet planes leave in the sky. The length, thickness, and curvature of the tracks enables the physicist to decide which of the 200-odd elementary particles has caused it, and also to identify particles previously unknown. But the fundamental lesson which the bubble chamber and other sophisticated instruments teach the physicist is that on the subatomic level, our concepts of space, time, matter, and conventional logic no longer apply. Thus, two particles may collide and break into pieces, but these pieces may turn out to be not smaller than the original particles, because the kinetic energy liberated in the course of the collision has been transformed into mass. Or a photon, the elementary unit of light, which has no mass, can give birth to an electron-positron pair, which does have mass. And that pair might subsequently collide, and by the reverse process transform itself into a photon. The fantastic events in the bubble chamber, which have been compared to the dance of Shiva, with its rhythmic alternations of creation and destruction. Here's that diagram or picture. And it says, diagram tracing a bubble chamber photograph of subatomic events from a photo CERN, courtesy of European Organization for Nuclear Research, Geneva. The caption, which leaves non-physicists none the wiser, reads, interaction in the heavy liquid bubble chamber, Gargamel. At A, an incident antiproton which enters the chamber at C-plane annihilates a resident proton, giving rise to a positive V and negative V pion, a neutral pion, and two gamma rays, each of which converts at D into an electron-positron pair. A second event is recorded where a particle entering at E interacts at B and produces two antiprotons and two positive V pions, one of which collides subsequently twice with resonant particles. So, all this is a long way from the beguiling simple Rutherford Bohr model of the beginning of our century that represented atoms as miniature solar systems in which negatively charged electrons circle like planets around a positively charged nucleus. Alas, the model ran into one paradox after another. The electrons were found to behave quite unlike planets. They kept jumping from one orbit into another without passing through the space between them, as if the Earth were instantaneously transferred into the orbit of Mars in a single jump, ignoring space. The orbits themselves were not well-defined trajectories, but wide, blurred tracks appropriate to the wave aspect of the electron, which was smeared all over the orbit, and it became as meaningless to ask at what exact point in space the electron was at a given moment, as it was meaningless to try to pin down a wave. As Bertrand Russell has put it, the idea that there is a hard little lump there, which is the electron or proton, is an illegitimate intrusion of common sense notions derived from touch. The atomic nuclei in the model did not fare better than the orbiting planets. The nuclei turned out to be the compounds of particles, mainly protons and neutrons, held together by other particles and forces which defy any visual model or representation in terms of our sensory experience. According to one hypothesis, neutrons and protons race around inside the nucleus with velocities of about 40,000 miles per second, a quarter of the speed of light. As Capra put it, Nuclear matter is thus a form of matter entirely different from anything we experience up here in our macrocosmic environment. We can perhaps picture it best as tiny drops of an extremely dense liquid which is boiling and bubbling most fiercely. In earlier books, I've discussed some of the most notorious paradoxes of quantum physics. Thomson's experiments, which made the same electron go through two minute holes in a screen at the same time, which Sir Cyril Burton commented is more than a ghost can do. The paradox of Schrödinger's cat, which can be shown to be both alive and dead at the same time. Feynman's diagrams, which particles are made to move for a brief instant backward in time, which earned him the Nobel Prize in 1965. And the Einstein-Podolsky-Rosen paradox, or EPR paradox, to which I shall briefly return. The situation has been summed up by Heisenberg himself, one of the chief architects of quantum theory. The very attempt to conjure up a picture of elementary particles and think of them in visual terms is wholly to misrepresent them. Atoms are not things. The electrons which form an atom's shells are no longer things in the sense of classical physics, things which could be unambiguously described by concepts like location, velocity, energy, size. When we get down to the atomic level, the objective world in space and time no longer exists. Werner Heisenberg will probably be remembered as the great iconoclast who put an end to causal determinism in physics, and thereby in philosophy, by his celebrated principle of indeterminacy, which is as fundamental to modern physics as Newton's laws of motions were to classical mechanics. I have tried to convey its meaning by a rather simplistic analogy. A certain static quality of many Renaissance paintings is due to the fact that the human figures in the foreground and the distant landscape in the background are both in sharp focus, which is optically impossible. When we focus on a close object in the background gets blurred and vice versa. The principle of indeterminacy implies that in studying the subatomic panorama, the physicist is confronted with a similar predicament, though of course for quite different reasons. In classical physics, a particle must at any time have a definite location and velocity on the subatomic level. However, the situation turns out to be radically different. The more accurately the physicist is able to determine the location of an electron, for instance, the more uncertain its velocity becomes, and vice versa. The more exactly he is able to determine the particle's velocity, the more blurred, i.e. indeterminate, its location becomes. This indeterminacy is not caused by the imperfection of our techniques of observation, but by the inherently dual nature of the electron as both particle and wavicle, which makes it practically and theoretically impossible to pin down. But this implies nothing less than that down on the subatomic level, the universe at any given moment is in a quasi-undecided state, and that its state in the next moment is to some extent indeterminate or free. Again, fluid or liquid. Thus, if an ideal photographer with a perfect camera took a picture of the total universe at any given moment, the picture would be to some extent fuzzy, owing to the indeterminate state of its ultimate constituents. Because of this fuzziness, physicists' statements about subatomic processes can only refer to probabilities, not to certainties. In the micro world, the laws of probability supplant those of causality. Nature is unpredictable, to quote Heisenberg once more. Thus, for the last 50 years, since the advent of quantum theory, it has become a commonplace among physicists of the dominant school, the so-called Copenhagen school, that the strictly deterministic mechanistic worldview can no longer be upheld. It has become a Victorian anachronism. The 19th century model of the universe as a mechanical clockwork is a shambles, and since the concept of matter itself has been dematerialized, materialism can no longer claim to be a scientific philosophy. I have quoted some of the giants, most of them Nobel laureates, who were jointly responsible for dismantling the antiquated clockwork, and attempted to replace it by a more sophisticated model, sufficiently flexible to accommodate logical paradoxes and wild theories previously considered unthinkable. During this half-century, countless new discoveries have been made, by radio telescopes scanning the skies and in the bubble chambers recording the subatomic dance of Shiva. But no satisfactory model and no coherent philosophy has yet emerged comparable to that of classical Newtonian physics. One might describe this post-Newtonian era as one of the periods of creative anarchy which recur in the history of every science when the old concepts have become obsolete and the breakthrough leading to a new synthesis is not yet in sight. At the time of writing, theoretical physics itself seems to be immersed in a bubble chamber with the weirdest hypotheses crisscrossing each other's tracks. I shall mention a few which seem pertinent to our theme. First, there have been some eminent physicists, among them Einstein, de Broglie, Schrödinger, Vigier, and David Bohm, who were unwilling to accept the indeterminacy and acausality of subatomic events, which in their opinion amounted to saying that these events were ruled by blind chance. Einstein's famous phrase, "God does not play dice with the world," reflects this attitude. They were inclined to believe in the existence of a substratum below the subatomic level which ruled and determined the seemingly indeterminate processes. This was called the theory of hidden variables, which, however, has been abandoned even by its staunchest supporters because it seemed to lead simply nowhere. But although unacceptable to the physicists, the hidden variables provided a fertile field for metaphysical and parapsychological theorizings. Theologians proposed that divine providence might work from within the fuzzy gaps in the matrix of physical causality, the God of the gaps. Sir John Eccles, Nobel laureate in physiology, proposed that the quantum indeterminacy of critically poised neurons in the brain made room for the exercise of free will. In the active cerebral cortex, within 20 milliseconds, the pattern of discharge of even hundreds of thousands of neurons would be modified as a result of an influence that initially caused the discharge of merely one neuron. Thus, the neurophysiological hypothesis is that the will modifies the spatio-temporal activity of the neuronal network by inserting spatio-temporal fields of influence that become affected through this unique detector function of the active cerebral cortex. The above implies that the action of individual minds on their own brains. The above applies to the action of individual minds on their own brains. In the concluding sections of his book, however, Eccles includes ESP and PK psychokinesis in his theory. He accepts the experimental results of Rhine and his school as evidence for a generalized two-way traffic between mind and matter and of direct communication channels between mind and mind. He believes that ESP and PK are weak and irregular manifestations of the same principle which allows an individual's mental volition to influence his own material brain, and the material brain to give rise to conscious experiences. The theory is not worked out in detail, but it is indicative of current trends of thought among enlightened neurophysiologists. From the late Sir Charles Sherrington to Penfield and Gray Walter, whom I've quoted in earlier works. It is also interesting to note that Penfield, the neurologist, received an unduly neglected hypothesis by Eddington, the astronomer, which postulated a correlated behavior of the individual particles of matter which he, Eddington, assumed to occur for matter in liaison with mind. The behavior of such matter would stand in sharp contrast to the uncorrelated or random behavior of particles that is postulated in physics. Thus, matter in liaison with mind displays specific properties not otherwise found in the realm of physics, a proposition not far removed from panpsychism. Another astronomer, V.A. Fursoff, suggested that mind was a universal entity or interaction of the same order as electricity or gravitation, and there must be a modulus of transformation analogous to Einstein's famous equation E equals mc squared. In other words, as matter can be transformed into physical energy, so physical energy must be transformable into psychic energy and vice versa. In recent years, there has been a spate of such theories intended to bridge the gap between quantum physics and parapsychology, which sound like science fiction, but the same remark applies, as we have seen, to the basic proposition of modern physics itself. Thus, the brilliant Cambridge mathematician Adrian Dobbs has put forward an elaborate theory of telepathy and precognition, in which hypothetical cytrons, with properties similar to the neutrinos, were regarded as the carriers of ESP phenomena capable of impinging directly on neurons in the recipient's brain. Among more recent writers, Dr. E. Harris Walker, a ballistics expert, has developed an ingenious quantum mechanical theory in which the hypothetical hidden variables are identified with consciousness as non-physical but real entities, independent of space and time, and connected to the physical world by means of the quantum mechanical wave function. His theory includes parapsychological phenomena, but it involves advanced mathematics and is altogether too technical to be discussed here. And that makes me think of gematria, how things really fold back down into numerical formulae, but then unfold into they can unfold into actual, physical things, geometric emergence. Lifting our sights from the bubble chamber to the starry skies, our common sense notions of space-time and causality turn out to be as inadequate as when we try to apply them to the subatomic domain. In the relativistic universe, space is curved and the flow of time is speeded up or slowed down according to the timekeeper's state of motion. Moreover, if parts of the universe are furnished with galaxies of antimatter, which many astronomers believe to be the case, there is a fair chance that in these galaxies the flow of time is reversed. Switching back from macrocosms to microcosms, we remember that in Feynman's diagrams, particles are supposed to move for a short while backwards in time. Heisenberg himself endorsed this hypothesis. The only consolation when faced with the paradoxes of quantum theory is the assumption that in very small regions of space-time, of the order of magnitude of the elementary particles, the notions of space and time become unclear. i.e., in very small intervals, even the concepts of earlier and later can no longer be properly defined. Of course, nothing is altered in space-time on the large scale, but we must bear in mind the possibility that experiment may well prove that small-scale space-time processes may run in reverse to the causal sequence. Of course, nothing is altered in space-time on the large scale, but we must bear in mind the possibility that experiment may well prove that small-scale space-time processes may run in reverse to the causal sequence. Thus, our medium-sized world, with its homely common-sense notions of space, time, and causality, appears to be sandwiched in between the macro and micro realms of reality, to which those parochial notions no longer apply. As Sir James Jeans wrote, "The history of physical science in the 20th century is one of progressive emancipation from the purely human angle of vision. On the macrocosmic scale of large distances and high speeds, relativity played havoc with that vision. On the microcosmic scale, relativity combined with quantum theory had the same effect. The physicist's concept of time is totally different today from what it was during Queen Victoria's reign. The most eminent among contemporary astronomers, Sir Fred Hoyle, has put it in his provocative way. You're stuck with a grotesque and absurd illusion, the idea of time as an ever-rolling stream. There's one thing quite certain in this business: the idea of time as a steady progression from past to future is wrong. I know very well we feel this way about it subjectively, but we're the victims of a confidence trick. But if the irreversibility of time is derived from a confidence trick, that is, from a subjective illusion, we are no longer justified in excluding on a priori grounds the theoretical possibility of precognitive phenomena such as veridical dreams. The logical paradox that predicting a future event must prevent it or alter its course is at least partially or partly circumvented by the indeterminateness of the future in modern physics and the probabilistic nature of all forecasts. The revolution in physics, which thus transformed our worldview, took place in the 1920s, but in the second half of our century, it took an even more surrealistic turn. At the time of writing, the universe appears to be pockmarked with so-called black holes. The term was coined by John A. Wheeler, a professor of physics at Princeton University and a leading figure among contemporary physicists. Black holes are hypothetical pits or sumps in distant space into which the mass of a burnt-out star, which has suffered gravitational collapse, is sucked at the speed of light, to be annihilated and vanish from our universe. The loci at which these apocalyptic events take place are referred to as singularities in the continuum. Here, according to the equations of general relativity, the curvature of space becomes infinite, time is frozen, and the laws of physics are invalidated. The universe is turning out to be a very odd place indeed, and we do not need ghosts to make our hair stand on end. One might be tempted to ask the naive questions where the matter which has fallen into the black hole goes, for not all of it can have been converted into energy. Wheeler has a tentative answer to that. It might emerge in the shape of a white hole somewhere in another universe located in superspace, his italics. The stage on which the space of the universe moves is certainly not space itself. Nobody can be a stage for himself. He has to have a larger arena in which to move. The arena in which space does its changing is not even the space-time of Einstein, for space-time is the history of space changing with time. The arena must be a larger object, superspace. It is not endowed with 3 or 4 dimensions. It's endowed with an infinite number of dimensions. Any single point in superspace represents an entire 3-dimensional world. Nearby points represent slightly different 3-dimensional worlds. Superspace, or hyperspace, has been an old standby of science fiction, together with the notion of parallel universes in reversed or multidimensional time. Now, thanks to radio telescopes and particle accelerators, they are acquiring academic respectability. The stranger the hard, experimental data, the stranger the theories which attempt to account for them. Wheeler's version of superspace has some remarkable features. The space of quantum geometrodynamics can be compared to a carpet of foam spread over a slowly undulating landscape. The continual microscopic changes in the carpet of foam as new bubbles appear and old ones disappear symbolize the quantum fluctuations in the geometry. Another remarkable attribute of Wheeler's superspace is multiple connectivity. This means, put into simple and oversimplified language, that regions which are in our homespun 3-dimensional world are far apart may be brought temporarily into direct contact through tunnels or holes in superspace. They are called wormholes. The universe is supposed to be crisscrossed with these wormholes, which appear and disappear in immensely rapid fluctuations, resulting in ever-changing patterns, a cosmic kaleidoscope shaken by an invisible hand. An essential feature of modern physics is its increasingly holistic trend based on the insight that the whole is as necessary for the understanding of its parts as the parts are necessary for understanding the whole. An early expression of this trend dating from the turn of the century was Mach's principle, endorsed by Einstein. It states that the inertial properties of terrestrial matter are determined by the total mass of the universe around us. There is no satisfactory causal explanation as to how this influence is exerted, yet Mach's principle is an integral part of relativistic cosmology. The metaphysical implications are fundamental, for it follows that from it, not only that the universe as a whole influences local terrestrial events, but also that local events have an influence, however small, on the universe as a whole. Philosophically minded physicists are acutely aware of these implications, which remind one of the ancient Chinese proverb, "If you cut a blade of grass, you shake the universe." Bertrand Russell flippantly remarked that Mach's principle, though formally correct, savors of astrology, while Henry Martineau, professor of physics at Yale, commented in an address to the American Society for Psychical Research, "Inertia is not intrinsic in the body, it is induced by the circumstance that the body is surrounded by the whole universe. We know of no physical effect conveying this action. Very few people worry about a physical agency transmitting it. As far as I can see, Mach's principle is as mysterious as your unexplained psychic phenomena, and its formulation seems to be almost as obscure." Switching once more from macro to microcosmos, we are confronted with the famous Einstein-Podolsky-Rosen paradox. It has been the subject of controversy ever since Einstein formulated it in 1933, and has recently been given a more precise expression by J.S. Bell, a theoretical physicist at CERN. Bell's theorem states that when two particles have interacted and then flown off in opposite directions, interference with one particle will instantly affect the other particle, regardless of the distance between them. The correctness of Bell's experimental results is not in dispute, but its interpretation poses a major problem because it seems to imply a sort of telepathy between the particles in question. This is how David Bohm, professor of theoretical physics at Birkbeck College, University of London, has summed up the situation, his italics. It is generally acknowledged that the quantum theory has many strikingly novel features. However, there has been too little emphasis on what is, in our view, the most fundamentally different new feature of all, i.e. the intimate interconnection of different systems that are not in spatial contact. This has been especially clearly revealed through the well-known experiments of Einstein, Podolsky, and Rosen. Recently, interest in this question has been stimulated by the work of Bell, who obtained precise mathematical criteria distinguishing the experimental consequences of this feature of quantum interconnectedness of distant systems. Thus, one is led to a new notion of unbroken wholeness, which denies the classical idea of analyzability of the world into separately and independently existent parts. I must mention one more apparently non-causal law of nature, the so-called Pauli exclusion principle. Wolfgang Pauli, whom I've quoted before, got the Nobel Prize in 1945 for having discovered it. It says, very roughly speaking, that any one of the planetary orbits inside an atom can only be occupied by one electron at a time. If it were not so, chaos would result and the atom would collapse. But why is it so? The answer, or rather absence of an answer, is vividly indicated in this passage quoted from Martineau, compressed. Most of the organizing actions that occur in nature are brought about by the Pauli principle, which is simply a principle of symmetry, a formal mathematical characteristic of the equations which in the end regulate phenomena in nature. Almost miraculously, it calls into being the forces which bind atoms into molecules and molecules into crystals. The impenetrability of matter is its very stability can be directly traced to the Pauli exclusion principle. Now, this principle has no dynamic aspect to it at all. It acts like a force, though it is not a force. We cannot speak of it as doing anything by mechanical action. No, it is a very general and elusive thing, a mathematical symmetry imposed upon the basic equations of nature. These quotations, which could be multiplied indefinitely, do not represent solo voices, but rather a chorus of eminent physicists aware of the revolutionary implications of quantum theory and of the new cosmology, which are bound to transform man's image of the universe even more radically than the Copernican revolution had done. But, as already said, the general public is slow in becoming aware of this change. The dogmas and taboos of 19th century materialist science relating to space, time, matter, and energy, contained within a rigid framework of causality and determinism, still dominate the habits of thought of the educated public, which prides itself on its rational outlook, and feels compelled to deny the existence of ESP-type phenomena, which seemingly contradict the laws of nature. In fact, our physicists have been engaged over the last 50 years in ruthlessly discarding previously sacrosanct laws of nature and replacing them with obscure mental constructs which cannot be represented in three-dimensional space, and whose quasi-mystical implications are hidden in technical jargon and mathematical formalism. If Galileo were resurrected, he would certainly accuse Heisenberg, Pauli, et al. Of dabbling in occult fancies. Curiously enough, during the same period, parapsychology took on a more hard-nosed appearance by relying more and more on statistical methods, rigorous controls, mechanical gadgets, and electronic computers. Thus, the climate in the two camps seem to be changing in opposite directions. Rhine's successors are sometimes accused of drab pedantry, while Einstein's successors have been accused of flirting with ghosts in the guise of particles which have no mass, no weight, nor any precise location in space. These convergent trends are certainly significant, but that does not mean that physics will provide explanations for the phenomena of parapsychology in the near or even in the distant future. What both have in common is an attitude define common sense and define laws of nature previously considered as inviolable. Both are provocative and iconoclastic. And to say it once more, the baffling paradoxa of physics makes the baffling phenomena of parapsychology appear a little less preposterous. If distant regions of the universe can be brought into contact through wormholes in superspace, is telepathy still unthinkable? The analogies can be treacherous, but it is encouraging to know that if the parapsychologist is out on a limb, the physicist is out on a tightrope. There exists a type of phenomenon even more mysterious than telepathy or precognition, which has puzzled man since the dawn of mythology: the seemingly accidental meeting of two unrelated causal chains in a coincidental event, which appears both highly improbable and highly significant. Any theory which attempts to take such phenomena seriously must necessarily involve an even more radical break with our traditional categories of reasoning than the pronunciamentos of Einstein, Heisenberg, or Feynman. It is certainly no coincidence that it was Wolfgang Pauli, discoverer of the exclusion principle, who collaborated with Carl Gustav Jung on the latter's famous essay, Synchronicity and Acausal Connecting Principle. Jung coined the term synchronicity for the simultaneous occurrence of two or more meaningfully but not causally connected events, and he claimed that the acausal factor behind such events is to be regarded as equal in rank to causality as a principle of explanation. I have often come up against the phenomena in question, Jung wrote, and could convince myself how much these inner experiences meant to my patients. In most cases, they were things which people do not talk about for fear of exposing themselves to thoughtless ridicule. I was amazed to see how many people have had experiences of this kind and how carefully the secret was guarded. Apparently, the Swiss are more secretive by nature than the British, for ever since I wrote The Roots of Coincidence, I have been inundated with coincidences in readers' letters. The most revealing among these were written by people who started by solemnly affirming that to attribute significance to coincidences is sheer nonsense, yet could not resist the urge to tell their own favorite believe it or not story. Could it be that inside every hard-nosed skeptic there's a soft-nosed mystic crying to be let out? Readers who share an interest in the collecting of coincidences will find a fair selection in the challenge of chance. While working through this vast amount of material, some distinct patterns begin to emerge, although they often overlapped, while in other cases it seemed doubtful whether some event within astronomical odds against chance should be interpreted as a manifestation of classical ESP or in terms of acausal synchronicity. Thus, in the library type of cases, you search for an elusive reference, open a fat volume at random, and there it is. In the Deus Ex Machina type of episodes, there is seemingly providential interposition just in the nick of time to solve a problem, or avert a disaster, or fulfill a premonition. It is interesting to note that this intercession occurs indiscriminately on tragic or trivial occasions. A subcategory in this group is the seemingly miraculous recovery of lost property, usually of sentimental, not monetary value. In the poltergeist cases, emotional tensions, usually in unstable adolescence, coincide with gross physical happenings, again regardless whether the effect is traumatic or grotesque. Among the frequent convergent or confluential events, as one may call this type of coincidence, are unlikely encounters, although many of these might seem to be induced by ESP. Worst of all, from a rational point of view, are the clusterings of names, numbers, addresses, and dates. Lastly, there is a wealth of well-authenticated cases of premonitions or warnings of impending disasters, but here it is particularly difficult to make distinction between ESP and synchronicity or confluential events. Even more frustrating is the attempt to draw a line between significant coincidences, which seem to be contrived by some unknown agency beyond physical causation, and trivial coincidences due to chance alone. For any such attempt must invoke the laws of probability, which are full of pitfalls, as we shall presently see. Jung's essay on synchronicity, published in 1952, was partly based on Paul Kammerer's book Das Gesetz der Serie. Published in 1919, Kammerer was the brilliant Viennese experimental biologist of Lamarckian persuasion who was accused of faking his results and committed suicide in 1926 at the age of 45. He was throughout his life fascinated by coincidences, and from the age of 20 to 40 kept a logbook of them, as Jung also did. It says, see the case of the midwife toad, which has a lot of good stuff about that. Kammerer defined his concept of seriality as the concurrence in space or recurrence in time of meaningfully but not causally connected events. His book contains exactly 100 selected samples classified with the meticulousness of a biologist devoted to taxonomy. He regarded single coincidences as merely the tips of the iceberg which happened to catch the eye among the ubiquitous manifestations of seriality. He thus reversed the skeptic's argument that we tend to see significance everywhere because of the multitude of random events. We only remember those which are significant. At the end of the first classificatory part of his book, Kammerer concluded, "So far we have been concerned with the factual manifestations of recurrent series without attempting an explanation. We have found that the recurrence of identical or similar data in contagious areas of space or time is a simple empirical fact which has to be accepted and which cannot be explained by coincidence, or rather which makes coincidence rule to such an extent that the concept of coincidence itself is negated." In the second theoretical part of his book, Kammerer develops this theory that coexistent with physical causality, there is an acausal principle active in the universe which tends toward unity and variety. In some respects, it is comparable to that other mysterious force, universal gravity, but whereas gravity acts indiscriminately on all matter, this hypothetical factor acts selectively to make like and like converge in space and time. It correlates by affinity or some sort of selective resonance, like tuning forks vibrating on the same wavelength. By what means this acausal agency interferes with the causal order of things we cannot know, since it operates outside the known laws of physics. In space, it produces confluential events related by affinities of form and function, in time, similarly related series. And this is like the associated grouping in Dark Doorway of the Beast. We thus arrive at the image of a world mosaic or cosmic kaleidoscope, which, in spite of constant shufflings and rearrangements, also takes care of bringing like and like together. One need not be a professional gambler to feel attracted by Kammerer's law of seriality. Most languages have a phrase or proverb for it. Das Gesetz der Serie is a cliché in German. The equivalent of it never rains, but it pours. Some people seem to become coincidence-prone as others become accident-prone. At the end of his book, Kammerer expresses his belief that seriality is ubiquitous and continuous in life, nature, and cosmos. It is the umbilical cord that connects thought, feeling, science, and art with the womb of the universe that gave birth to them. The main difference between Kammerer's seriality and Jung's synchronicity is that the former emphasizes serial happenings in time, though he also includes simultaneous coincidental events, whereas the latter's emphasis is on simultaneous events, but also includes precognitive dreams, which may have occurred several days before the event. Kammerer based his theory partly on the analogy with gravity, partly on the periodic cycles in biology and cosmology. Some of his excursions into physics contain naive errors. Other passages show tantalizing flashes of intuition, so much so that Einstein commented favorably on the book. He called it original and by no means absurd. Jung, on the other hand, used Pauli quasi as a tutor in theoretical physics, but in the end made little use of it. His explanations of the acausal factor were utterly obscure, invoking the collective unconscious and its archetypes. This was sadly disappointing, but it helped to turn synchronicity into a cult word. The part played by Pauli in these developments is of special interest. Pauli shared Kammerer's and Jung's belief in non-causal, non-physical factors operating in the universe. Was not his own exclusion principle acting like a force, though it is not a force? He probably had a more profound insight than most of his colleagues into the limitations of science. Besides, like Jung, he was haunted all his life by poltergeist-like phenomena. When he was 50 and a Nobel laureate, he wrote a penetrating study on science and mysticism, exemplified in the works of Johannes Kepler. It was first printed as a monograph by the Jung Institute in Zurich. Toward the end of the essay, Pauli wrote, "Today we have the natural sciences, but no longer a philosophy of science. Since the discovery of the elementary quantum, physics was obliged to renounce its proud claim to be able to understand its principle, the whole of the world. In principle, the whole of the world. But this predicament may contain the seed of further developments which will correct the previous one-sided orientation and will move towards a unitary worldview in which science is only a part in the whole." This kind of philosophical doubt about the meaning behind it all is not unusual among scientists when they reach the age of 50. One might almost call it the rule. But Pauli went further than trying to devise physicalistic theories to explain ESP or synchronicity. He felt that this was hopeless and that it was more honest to accept that these phenomena were the visible traces of invisible acausal factors, like the bubble chamber charts of invisible particles. Pauli's revolutionary proposal was to extend the concept of non-causal events from the micro-world, where its legitimacy was recognized, to the macro-world, where it was not. He may have hoped that by joining forces with Jung, they might be able to work out an acausal theory which made some sense of paranormal phenomena. The result, as already said, was disappointing. The upshot of Jung's essay on synchronicity was a curious diagram on which Jung says he and Pauli finally agreed. This is the diagram. Indestructible energy, space-time continuum, constant connection through effect, causality, inconstant connection through contingency, similarity, or meaning. Jung offers no explanation as to how the scheme is meant to work, and his comments on it are so obscure that I must leave it to the interested reader to look them up in the original. One cannot help being reminded of the biblical mountain whose labors gave birth to a mouse, but it was quite a symbolic mouse nevertheless. It was for the first time that the hypothesis of acausal factors at large in the universe was given the joint stamp of respectability of a psychologist and a physicist, both of international renown. The belief in connections beyond physical causality did not, of course, originate with Kammerer or Jung. Its immediate ancestry can be traced back to Schopenhauer, who had considerable influence over both Freud and Jung. Schopenhauer taught that physical causality was only one of the principles ruling the world. The other was a metaphysical entity, a kind of universal consciousness compared to which individual consciousness is as a dream compared to reality. He wrote, "Coincidence is the simultaneous occurrence of causally unconnected events. If we visualize each causal chain progressing in time as a meridian on the globe, then we may represent simultaneous events by the parallel circles of latitude. All the events in a man's life could accordingly stand in two fundamentally different connections. This idea of unity and diversity can be followed all the way back to the Pythagorean harmony of the spheres and the Hippocratic sympathy of all things. There is one common flow, one common breathing, all things are in sympathy. The doctrine that everything in the universe hangs together partly by mechanical causes, but mainly by hidden affinities, which also account for apparent coincidences, provided not only the foundation for sympathetic magic, astrology, and alchemy, it also runs as a leitmotif through the teachings of Taoism and Buddhism, the Neoplatonists and the philosophers of the early Renaissance. It was neatly summed up by, among many others, Pico della Mirandola in 1550. Firstly, there is the unity in things whereby each thing is at one with itself, consists of itself, and coheres with itself.
Secondly, there is the unity whereby one creature is united with the others, and all parts of the world constitute one world. In the terms of the present theory, the first half of the above quotation reflects the working of the self-assertive, the second of the self-transcending or integrative tendency on a universal level. We may also compare Pico's statement with the consensus of contemporary physicists. It is impossible to separate any part of the universe from the rest. The essence of both quotations, separated by 4 centuries, is a holistic view of the universe which transcends physical causality. One of the best-kept secrets of the universe relates to the question how the subatomic microworld of particles, which are at the same time wavicles, which defy strict determinism and mechanical causation, how this ambiguous undulating carpet of foam gives rise to the solid, orderly macroworld of everyday experience ruled by strict causality. The modern scientist's answer is that the seemingly miraculous feat of creating order out of disorder must be seen in light of the theory of probability, or the law of large numbers. But this law, like Pauli's exclusion principle, is not explainable by physical forces. It hangs, so to speak, in the air. A few examples will illustrate the point. The first 2 are classic cases quoted from Warren Weaver's book on the theory of probability. The statistics of the New York Department of Health show that in 1955, the average number of dogs biting people reported per day was 75.3, and in 1956, 73.6. In 1957, 73.5, in 1958, 74.5, and in 1959, 72.4. A similar statistical reliability was shown by cavalry horses administering fatal kicks to soldiers in the German army of the last century. They were apparently guided by the so-called Poisson equation of probability theory. Murderers in England and Wales, however, different in character and motives, displayed the same respect for the laws of statistics. Since the end of the First World War, the average number of murders over successive decades was 1920 through 9, 3.84 per million of the population, 1930 through 9, 3.27 per million, 1940 through 9, 3.92 per million, 1950 through 9, 3.3 million, 1960 through 9, approximately 3.5 per million. These bizarre examples illustrate the paradoxical nature of probability, which has puzzled philosophers ever since Pascal initiated that branch of mathematics, and which von Neumann, the greatest mathematician of our century, called black magic. The paradox consists of the fact that the theory of probability is able to predict with uncanny precision the overall results of a large number of individual events, each of which is in itself unpredictable. In other words, we are faced with a large number of uncertainties producing a certainty. A large number of random events creating a lawful total outcome. But paradoxical or not, the law of large numbers works. The mystery is why and how it works. It has become an indispensable tool of physics and genetics, of economic planners and insurance companies, gambling casinos, and opinion polls, so much so that we take the black magic for granted. Thus, when faced with such bizarre examples of probability lore as the dogs or cavalry horses, we may be mildly puzzled or amused without realizing the universal nature of the paradox and its relevance to the problem of chance and design, freedom and necessity. In nuclear physics, we find striking analogies to the unpredictable dogs producing predictable statistics. A classic example is radioactive decay, where totally unpredictable radioactive atoms produce exactly predictable overall results. The point in time at which a radioactive atom will suddenly disintegrate is totally unpredictable both theoretically and experimentally. It is not influenced by chemical or physical factors like temperature or pressure. In other words, it does not depend on the atom's past history nor on its present environment. In the words of Professor Bohm, it does not have any causes. It is completely arbitrary in the sense that it has no relationship whatsoever to anything else that exists in the world or that ever has existed. Italics in the original. And yet it does have a hidden, apparently acausal relationship with the rest of the world, because the so-called half-life period of any grain of radioactive substance, i.e. the time required for half of the atoms in the grain to disintegrate, is rigorously fixed and predictable. The half-life of uranium is 4.5 million years. The half-life of radium-A is 3.825 days. The half-life of thorium-C is 60.5 minutes, and so on, down to the millionth of seconds. However, there may be fluctuations in the rate of decay of the grain. At some stages on the road to the half-life date, there might be an excess or deficit of decayed atoms, which threatens to upset the timetable. But these deviations from the statistical mean will soon be corrected and the half-life date rigorously kept. By what agency is this controlling and correcting influence exerted, since the decay of individual atoms is unaffected by what goes on in the rest of the grain? How do the dogs of New York know when to stop biting and when to make up the daily quota? How are the murderers in England and Wales made to stop at 4 victims per million? By what mysterious power is the roulette ball induced after a glut of reds to restore the balance in the long run? By the laws of probability or the laws of large numbers, we are told. But that law has no physical powers to enforce its dictates. It is impotent and yet virtually omnipotent. It may seem that I am laboring the point out of sheer perversity, but this paradox is indeed vital to the problem of causality. Since the causal chains which lead to the decay of individual atoms are ostensibly independent from each other, we must either assume that the fulfillment of the statistical prediction that my sample of thorium-C will have a half-life of 60.5 minutes is itself due to blind chance, which is absurd, or we must take the plunge and opt for some alternative hypothesis on the speculative lines of an acausal connecting agency, which is complementary to physical causality in the sense in which particle and wavicle, mechanical and mental, complement each other. Such an agency would operate in different guises on different levels in the shape of hidden variables, filling in the gaps of causality on the subatomic level, coordinating the activities of the physically independent thorium-C atoms to make them respect the half-life date, bringing like and like together in the confluential events of seriality and synchronicity, and perhaps generating the psi field of the parapsychologist. This may sound like a tall proposition, but is in fact no taller than the paradoxical phenomena on which it is based. We live submerged in a universe of undulating quantum foam, which ceaselessly creates weird phenomena by means transcending the classical concepts of physical causation. And there's a term called the quantum glue, and that happens when you add it up to equal 666, and it's just funny because it shows how these broken components, the quantum and glue, come to create this alignment of, this number that's solar and Saturnian, and I don't know, it's just an ironic key, makes me think of. The purpose and design of this acausal agency is unknown and perhaps unknowable to us, but intuitively we feel it somehow to be related to that striving towards higher forms of order and unity and variety which we observe in the evolution of the universe at large, of life on Earth, human consciousness, and lastly, science and art. One ultimate mystery is easier to accept than a little litter basket of unrelated puzzles. In his classic essay, What is Life?, which I've quoted before, Erwin Schrödinger took a similar line. He called the connecting link between the totally unpredictable subatomic events and their exactly predictable collective result the order from the disorder principle. He frankly admitted that it is beyond physical causation. The disintegration of a single radioactive atom is observable. It emits a projectile which causes a visible scintillation on a fluorescent screen. But if you're given a single atom, its probable lifetime is much less certain than that of a healthy sparrow. Indeed, nothing more can be said about it than this. As long as it lives, and that may be for thousands of years, the chance of its blowing up within the next second, whether large or small, remains the same. This patent lack of individual determination nevertheless results in the exact exponential law of decay of a large number of radioactive atoms of the same kind. Robert Harvey, co-author with Sir Alister Hardy and myself of The Challenge of Change, or The Challenge of Chance, commented on this passage by Schrödinger. Orthodox quantum theory attempts to resolve this paradox by asserting the probabilistic nature of matter at the microscopic level, but a further paradox remains, that of probability itself. The laws of probability describe how a collection of single random events can add up to a large-scale certainty, but not why. Why do not the million nuclei explode at once? Why should we expect that a symmetrically balanced penny will not fall heads on every toss from now to eternity? The question is evidently unanswerable. The order from disorder principle seems to be irreducible, inexplicably just there. To ask why is akin to asking why is the universe, or why has space 3 dimensions, if indeed it has. In the present theory, the order from disorder principle is represented by the integrative tendency. We have seen that this principle can be traced all the way back to the Pythagoreans. After its temporary eclipse during the reign of reductionist orthodoxies in physics and biology, it is once more gaining ascendancy in more sophisticated versions. I have mentioned the related concepts of Schrödinger's neg entropy, Cezanne Georgi's syntropy, Bergson's Elan Vital, etc. One might add to the list the German biologist Walterich, who coined the term anamorphosis, which von Bertalanffy adopted for nature's tendency to create new forms of life, and also L.L. White's morphic principle, or the fundamental principle of the development of pattern. What all these theories have in common is that they regard the morphic, the formative, or syntropic tendency, nature's striving to create order out of disorder, cosmos out of chaos, as ultimate and reducible principles beyond mechanical causation. The present theory is even more hazardous by explicitly suggesting that the integrative tendency operates in both causal and acausal ways, the two standing in a complementary relationship analogous to the particle-wave complementarity in physics. It is accordingly supposed to embrace not only the acausal agencies operating on the subatomic level, but also the phenomena of parapsychology and confluential events. We have seen that ESP and synchronicity often overlap, so that a supposedly paranormal event can be interpreted as a result of either as a result of ESP or as a case of synchronicity. But we are perhaps mistaken when we try to make a categorical distinction between the two. Classical physics has taught us that there are various manifestations of energy, including kinetic, potential, thermal, electrical, nuclear, and radiant energy, which can be converted into one another by suitable procedures like interchangeable currencies. The present theory, that in a similar way telepathy, clairvoyance, precognition, psychokinesis, and synchronicity are merely different manifestations under different conditions of the same universal principle, i.e. the integrative tendency operating through both causal and acausal agencies. How this is done is beyond our understanding, but at least we can fit the evidence for paranormal phenomena into the unified design. Among the basic requirements for the validation of a scientific experiment are its repeatability and predictability. Paranormal events, however, whether produced in the laboratory or spontaneously, are unpredictable, capricious, and relatively rare. This is one of the reasons why skeptics feel justified in rejecting the results of some 40 years of rigorously controlled laboratory experiments in ESP and PK, in spite of the massive statistical evidence which, in any other field of research, would be considered as sufficient proof for the reality of the phenomena. But the criterion of repeatability applies only when the experimental conditions are essentially the same as in the original experiment, and with sensitive human subjects, the conditions are never quite the same in terms of mood, receptivity, or emotional rapport between subject and experimenter. Besides, ESP phenomena nearly always involve unconscious processes beyond voluntary control, and if the phenomena are in fact triggered by acausal agencies, it would be naive to expect that they can be produced at will. There is, however, another explanation for the apparent rarity and capriciousness of paranormal phenomena, which is of special interest in our context. It was, I believe, originated by Henry Bergson and has been taken up by various writers on parapsychology. Thus, for instance, H.H. Price, former Wykeham professor of logic in Oxford, It looks as if telepathically received impressions have some difficulty in crossing the threshold and manifesting themselves in consciousness. There seems to be some barrier or repressive mechanism which tends to shut them out from consciousness, a barrier which is rather difficult to pass, and they make use of all sorts of devices for overcoming it. Often they can only emerge in a distorted and symbolic form, as often unconscious mental contents do. It is a plausible guess that many of our everyday thoughts and emotions are telepathic or partly telepathic in origin, but are not recognized to be so because they are so distorted and mixed with other mental contents in crossing the threshold of consciousness. The Cambridge mathematician Adrian Dobbs, commenting on the extract I quoted, went straight to the heart of the matter. This is a very interesting passage. It evokes the picture of either the mind or the brain as containing an assemblage of selective filters designed to cut out unwanted signals on neighboring frequencies, some of which get through in a distorted form, just as in ordinary radio reception. Cyril Burt, former professor of psychology, University College London, took up the same idea. Our sense organs and our brain operate as an intricate kind of filter which limits and directs the mind's clairvoyant powers, so that under normal conditions, attention is concentrated on just those objects or situations that are of biological importance for the survival of the organism and its species. As a rule, it would seem, the mind rejects ideas coming from another mind as the body rejects grass coming from another body. At this stage, the reader may have experienced a feeling of déjà vu, because earlier on I discussed some other filter theories related to the mechanisms of perception in the process of evolution. In fact, the hypothesis that there is a filtering apparatus which protects us against unwanted ESP signals is merely an extrapolation from what we know about normal sensory perception. We remember William James's famous blooming, buzzing multitude of sensations which are constantly bombarding our sensory receptors, and particularly the eyes and ears. Our minds would be engulfed by chaos if we were to attend to each of these millions of stimuli impinging on them. Thus, the central nervous system and the brain have to function as a multi-leveled hierarchy of scanning, filtering, and classifying devices, which eliminate a large proportion of the sensory input as irrelevant noise, and assemble the relevant information into coherent patterns before it is presented to consciousness. By analogy, a similar filtering apparatus might protect our rational minds against the blooming, buzzing multitude of messages, images, intuitions, and coincidental happenings in the psychomagnetic field surrounding us. We can draw a further analogy between the filtering hierarchies, which protect the mind from irrelevant stimuli of sensory or extrasensory origin, and the genetic microhierarchies, which protect the hereditary blueprint in the chromosomes against biochemical intrusions and harmful mutations which otherwise would play havoc with the stability and continuity of the species. Moreover, I've felt emboldened to suggest that the existence of a Lamarckian microhierarchy of selective filters, which prevents acquired characteristics from interfering with the hereditary endowment, except for those select few which respond to some vital need of the species, resulting from persistent pressures of the environment over many generations, until they seep through the filter and become part of the hereditary endowment of the human embryo, like the thick skin on its soles. This is undeniably an acquired characteristic which has become hereditary, yet in conformity with the prevailing dogma we are asked to believe that it happened by pure chance. In fact, the Lamarckians, as we have seen, found themselves in the same type of predicament as the parapsychologists. They were unable to produce a repeatable laboratory experiment. Even apparently clear-cut cases of Lamarckian inheritance were open to different interpretations, to polemics pursued with quasi-theological passions, and as a last resort to accusations of fraud. Moreover, the Lamarckians were unable to provide a physiological explanation for the inheritance of acquired characteristics, just as the parapsychologists are unable to produce a physical explanation of ESP phenomena. This curious parallel seems to have gone unnoticed by both Lamarckians and parapsychologists. I have found no mention of it in the literature of either school, yet it seems to me relevant because both heresies show up in the shortcomings of scientific orthodoxies without being able to offer a comprehensive alternative beyond Johansson's great central mystery, or Grass's. It seems possible that confronted by these problems, biology is reduced to helplessness and must hand over to metaphysics.